Hey there. Honors Algebra 2 with Mrs. Krantz. We kind of have to get right to conics today. I want to work through a bunch of review problems for a test you guys are having in about a week. So Honors Algebra 2 with Mrs. Krantz, conic review. What is a conic? Do you know what a conic is? Honors Algebra 2 with Mrs. Krantz, conic section review. What is the definition of a conic? Think about it. I'm probably going to post this on April 23rd, which is a Thursday, 1 week before the test, which is the last day of April and the first day of May. Two-part test. Your first online test. So what is a conic? Think about cones, and it's double cones, and its shapes formed by the intersection of a double cone and a plane. And say this is the plane. And you can get one of four shapes. Okay, that's definition of a conic. All right, so first we're going to talk about the ellipse. There are quite a few story problems that go along with conics. We haven't done too many, just for the sake of a number of reasons. But here is one. An architect has designed an elliptical pool. I'm sure you've seen these somewhere for a lobby in a new hotel. All right, if the coordinate plane is placed on the lobby, superimposed on top of it, the centers of the lobby and the pool are both at 0, 0. All right. The outline of the elliptical pool can be modeled by this equation. Units are in meters. Find the foci of the ellipse and the length of the major axis. All right, first, what's wrong with this? We have to write it in standard form, which means I need to divide everything by 108 to make this equal to 1. All right. So let's see, is 12 times 9, 108. We'll verify. Yes. All right, so when we divide by 108, we get x squared over 12 plus y squared over 9 equals 108. Why do I have to write in standard form? Well, I need to figure out what is the major and what's the minor axis. Right? Is it x major or is y the major? Well, for an ellipse, the way you know is that a is always the biggest. So a squared is under the x, so x is the major, y is the minor. All right. What would a be? The square root of 12, which is 2 square roots of 3. All right. Which is about what? What's square root 12? 3 point what? About 3.5. Okay. Or 3.46. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. Do I have to draw it? No, but I'm going to go ahead and draw it. Okay. We've got about 3.5, negative 3.5. What's b? Well, b is square root of 9, which is 3. All right, so we're going to have this elliptical pool. All right. And we're going to find the foci. So I have to find c. To find c, which Pythagorean theorem do I use? The regular Pythagorean theorem or the changed one? Well, for an ellipse, a is the biggest number. It's the largest number. So we're going to have b squared plus c squared equals a squared. So b squared is 9. C squared I don't know. A squared is 12. C squared is 3. C is the square root of 3. So where will the foci be? Well, it's about 1.7. Here. foci will be positive, negative, square root of 3, 0. Okay. Why would we want to know the foci? Well, an architect might want to put something there in the pool, right? Because placing things at the foci of an ellipse can be aesthetically pleasing. Right? That's one reason why. All right, lastly, we're going to find the length of the major. The length of the major is twice A. And that's 2 times 2 square root of 3. So that's 4 square root of 3 meters. And what's 4 square root of 3? If we're going to round, that's about 6.23 meters. All right. Foci. And the length of the major. All right, next problem. 2. A satellite is launched with a circular orbit around the Earth. It's at an altitude of 120 miles above the surface of the Earth. The diameter of the Earth is about 7,920 miles. Write an equation for the orbit of the satellite. The center is 0, 0. Okay. Center 0, 0. This is the Earth. We'll pretend this is the sphere, right? It's just a circle. All right, now where is this satellite? It's launched in a circular orbit. Oh, above the surface, 120. And then it's going around. I want to write the equation of this circle. Okay. Well, it is x minus h squared plus y minus k squared equals the radius squared. And the center is 0, 0, so hk. So I simply need the radius, right? The radius, I need this distance for my radius. Well, I know this is 120. What about this? Well, diameter is 7,920. What do I do to get the radius? You got it. Divided by 2. So this distance. All right. And then for the radius, I'm going to add 3,960 plus 120. So the radius is 4,080, and then we're going to square that. Ooh, big number. So we get x squared plus y squared equals, looks like 16,646,400. This is the equation for the satellite circular orbit. All right. Next problem. Conics review. Review for what? Test. Okay. Now, which conic is this? 2 branches, hyperbola. All right, we're going to find the equation of the hyperbola, so we got to read through this. Some ships navigate using LORAN. It's a system. The ship's equipment calculates the difference between the arrival times of simultaneously broadcast radio signals. The difference. The difference in arrival times indicates how much closer the ship is to one transmitter than the other. All points on the hyperbola shown in the diagram are 58 miles closer to one transmitter than the other. The transmitters are at the foci. They're 600 miles apart. It's 0, 0 and 600, 0. 1, 2, 3, 4, 5. Be right here. Find the equation of the hyperbola. Okay. So, what do I need for the equation of hyperbola? I need the center, HK, and I need A and B. All right? And I need to know which axis is the transverse, X or Y. Horizontal or vertical? Well, where are the foci? Where are the vertices? They're on the x, the horizontal. So x squared comes first. That'll be x, what? Where's the center? Right in the middle. Looks like my center is, hopefully you said 300, 0. Because this is 0 to 600 right in the middle is 300. So x minus 300, quantity squared over something minus, for hyperbola, y, that's minus 0 squared, so y squared, over something equals 1. Now, what do I need? I need A and I need B, okay? Do I have A? Do I have B? I actually don't think I have either. I don't have either. So what am I going to do? Well, what is this difference stuff between the arrival times? 58 miles closer. This is the very definition of a hyperbola. So let me pick a point on either branch of the hyperbola. I'll go like here. All right. And the difference between the distances from one focus to the other where the transmitters are. All right, so you've got this distance, and then I have this distance. And the difference is 58. So for instance, if this distance was 158, okay, what would this distance be? Well, 158 minus 58, this would be 100. That's what it's saying here. And this 58, that difference, which is K, is also equivalent to twice A. That 58 distance is this distance right here, 2A. Twice A. Right. So what will A be? Well, A will be half of 58, right? 29. Okay. What else do I know? Well, I didn't really know that, but we figured it out. That's the tougher part, right? We also know, not B, but we know C. C is the distance from the center to a focus, which is 300. Okay. So how am I going to find B? Well, for a hyperbola, it's the normal a squared plus b squared equals c squared. All right, so I'm going to get a squared, 841, plus b squared, I don't know, equals 300 squared. Big number. And then we're going to subtract, right? So b squared is, right? What are we doing? Okay, b squared, I don't even need b really, right? I need to know a squared, and I need to know b squared. Right? So my a squared will be, this number, 841, and b squared we just figured out, 89,159. Okay, here's the equation. All right. Don't be alarmed on a lot of story problems. Your numbers end up getting quite big. Okay, they can. All right, that's no problem. All right. Next one, is it a story problem? No. All right. Find the vertex, focus, and directrix, because this is which conic? With only a y squared, not an x squared and y squared. This is parabola. All right. So I'm going to put it in vertex form. That's the best way to find the vertex, I think. All right. So what should I do? Well, I'm going to put my y squared, then minus 8y. All right. Then I'm going to subtract 8x and minus 40. All right, we're going to solve this for x. Right. First, I got to complete the square. Let's take b, negative 8, divided by 2, negative 4, and square it. So I'm going to add 1 16 to both sides. Y minus 4 squared equals negative 8x minus what? 24, you got it. Now I'm going to solve for x. I'm going to add 24. And then divide everything by negative 8. So x equals, these cancel. I have 1 over negative 8. Negative 1/8. Y minus 4, quantity squared. 24 divided by negative 8 minus 3. All right. Vertex form. And from that, you can find the vertex. X equals A, y minus k, quantity squared, plus h. K. Remember, k always goes with the y. So the vertex is negative 3, positive 4. Right? Positive 4. And now what? Well, what kind of parabola is this? I know the vertex. Right? I'll put it over here, maybe. Negative 3, 4. 1, 2, 3. Which way is the point? Up, down, left, or right? Solve for x is pointing either right or left. Negative A means left. Right? I just need to know this because now I have to find the focus in the directrix, which means I need to find what letter? C. Right? And A is 1 over 4C. So A, 1 over 4C. This is why I have an eraser. A is negative 1/8 equals 1 over 4C. So 8 equals 4A. I keep putting it. C is 2, or you can think of it as negative 2, but I think of it as positive because it's a distance. All right. So where is the focus? The focus is inside the parabola. 1, 2 to the left. So negative 3, negative 4, negative 5. The focus is negative 5, 4. The directrix is a line 2 behind it. What's that directrix? It is x equals, if you said negative 1, you're right. Very good. All right. Parabolas. Next one, not a parabola. What is this going to be? Find the foci. Could be hyperbola, could be ellipse, but I see all plus. So this is an ellipse. All right, let's find the foci. Got to get it in standard form. So I'm going to put my 2, I'm going to put my x's together. I'm going to factor out a 2, and I have x squared plus 4x. Leave a spot for what? To complete the square. Okay, so put my x squared, my x's, my y squared, get my constant on the other side. All right, so now what I'm going to do, I'm going to take b, divide by 2 and square it, and that means I'm going to add 4. But did I add 4? Not quite. I really added 2 times 4, so I need to add 8 to the other side. So I get 2, and then I get x plus 2, quantity squared, plus y squared. On the other side, negative 4 plus 8, 4. Now I divide everything by what? 4 to get 1. All right, 2/4 is 1/2. That's 2. There we go. All right, standard form. Now, why did I do that? Well, I did that because I wanted to first figure out what? The center. What's the center of this thing? It's negative 2, 0. All right. Now, I don't have to graph it, but I'm going to. Sometimes it really helps. Okay. Then I need to know what's the major, x or y. What's the major axis? Well, a is the biggest number, so a squared, the biggest number is under y squared. So y, or in this case, a vertical line, is the major axis. All right, so this is the taller one. All right, and this is my b squared. Okay, so if I were to graph this, a is the square root of 4, which is 2. Like I'd go up 2, down 2. Okay. B is the square root of 2, which is what again? About 1.4. All right, so you'd have this. If you were to graph it, right? Pretend it's symmetrical. All right, now let's just find the foci. I need to find C. Right? So it is b squared plus c squared equals a squared, because a is the biggest distance on this. B squared is 2 plus c squared, I don't know, equals 4. Ooh, c squared is 2. C is the square root of 2. Just like B, that's fine. So where are the foci? So exact would be, I've got -2, and then positive negative square root of 2. And that's -2 and about positive negative 1.41. All right. There we go, foci. Next one, read back. Number 4, write the equation in standard form of an ellipse, right? Okay, so an ellipse, this isn't drawn perfectly. The center's 0, 0. So I'll have x squared, I'll have y squared equals 1, right? And it's a little bit hard to tell, but y is the major, longer than x. So a squared and then b squared. Right? Now, to write the equation, you need hk, which we know is 0, 0, and you need a and b. What do I have? What's this? This distance is b. So I know b squared, which is 4. Now what? I don't know a squared. I need to find a. What am I going to do? I don't know a squared. What can I do? Well, I have, this is a point, which is xy. So we're going to plug in -1 for x. And -1 squared is +1. And y is 2. 2 squared is 4. And now we're going to solve this for a. What should we do? Well, I'll subtract 1/4 from both sides. You get 3/4. Then this is the little rational equation we'll cross multiply. 3a squared equals 16. A squared equals 16 thirds. Now, I don't even have to find a. Beauty. I just actually need a squared and b squared. So I think we're ready to go. It's x squared over 4 plus y squared over, now a squared. But I don't want a complex fraction. So I'm going to do what to this second fraction? Get rid of this little 3 times by 3. And my final answer is x squared over 4 plus 3y squared over 16 equals 1. There we go. All right. A few more. Number 5, graph. Find the vertices, co-vertices. This is an ellipse then. Foci, length of major and minor. All right. What's wrong with this? This should equal 1. So what are we going to divide by to get 1? 5. Okay. 20 divided. I get 4x squared plus 4y squared over. Ooh. This is technically standard form, but I need to know what a squared and b squared are. I need to have it look like this. Okay. I need to know what's under this x squared and what's under this y squared. Okay. So I'm going to rewrite this. Right. 4x squared would be the same as x squared over what? Think reciprocal. Reciprocal of 4 is 1/4. Okay. I could go right back to standard form by multiplying the top and the bottom by 4. Okay. So reciprocal. Same thing here. Just do the reciprocal of 4/5. That's 5/4. So you need the reciprocal just to rewrite. Okay. Now, what's the major on this? Well, where's the bigger number? Under the y squared. So this is my a squared. The major is y. Okay. Okay. And the minor is the x. Okay. So what is b? B is the square root of 1/4, which is a half. What is a? A is the square root of 5 over the square root of 4, which is 2. Okay. What's that about? What is the square root of 5 divided by 2? It's about 1.12. So I'm going to graph this. Maybe I'll go by halves. B is half. Why is it major? Oh, here we are. You might even want to go by force on this, but so vertices are 0, positive, negative, square root of 5 over 2. Co-vertices are positive, negative, half, 0. Foci. Inside. All right, I used b squared, 1/4, plus c squared equals a squared, because a is the largest distance. 5/4 minus a 4, c squared is 1. Ooh, square root of 1. C is also 1. Very nice. What a foci. Right here. Foci are 0, positive, negative, 1. Nice. And lastly, lengths of the major and minor axes. Right. Major is twice a. Right. A is square root of 5 over 2. 2's cancel, square root of 5 units. Right. The minor is twice b. So 2 times b, which is a half, and you get 1 unit. Interesting. Length of the minor, length of the major. Nice. Okay, 3 more, I think. Conic test review. All right. Make sure you need to know your formulas, okay? We've been using a bunch of formulas on each problem. Okay. Now we are back to hyperbola formula. All right. An equation for hyperbola with vertices, positive, negative, square root of 7, 0. Ooh, so, Right. I have no idea how wide it is. All right. But why did I just draw that for the vertices? Well, I need to know what is the transverse axis, right? It's the x, okay? Also, I need to know the center. Well, the center is 0, 0, right? To write an equation hyperbola, you need hk and a and b, right? So this will be x squared over yx first, because transverse is x, minus y squared over what equals 1. Well, transverse, I want a squared under there. What's a squared? Well, this distance is a. This is a. Square root of 7 squared is 7. What's b squared? Ooh, I do not know. But I have a point, -4, 6. Ah. What am I going to do with that? Plug it in, x and y. Right? So -4 squared, that's 16 over 7, minus 6 squared, 36 over b squared equals 1. All right, let's solve this for b. I'm going to subtract 16 sevenths. So that's 7 sevenths minus 16 sevenths. That's negative how many sevenths? 9. Negatives will cancel out. Cross multiply. 9b squared equals 36 times 7. Save me a calculator. Divide by 9. 36 divided by 9 is 4, and 4 times 7 is 28. B squared is really all I need, right? I have a squared at b squared. What's the equation? X squared over 7 minus y squared over 28 equals 1. All right. Couple more, actually 2 more. Find the exact lengths of the major and the minor axes. All right. First, I gotta put this in standard form. Divide by what? Well, I want this to be 1. So I get 2x squared plus y squared over 2 equals 1. Okay. Now, this looks just fine to me. Right? What about this? I've gotta think reciprocal. This is standard form, but I've got to get it as x squared over something plus y squared over 2. What's the something? Reciprocal of 2, which is half. Okay. All right. So now, major I need A, minor I need B. Right? Well, A is the longest for an ellipse, so this would be a squared. This is b squared. So what's a? A is square root 2. Okay. So what's the length of the major? Twice a. Exact. Okay. What's the length of the minor? Twice, what's b? B is square root of 2. Sorry, 1 over square root of 2, right? Square root. And I'm going to rationalize. So b is 2, sorry, square root of 2 over 2. B. So twice b. 2's cancel. The minor is square root of 2 units. Nice. Next one, last one. All right, where are we at here? Determine the type of conic. Ooh, you've got 4 options, right? The type of conic. Graph, find all the appropriate info. Write exact values. Ooh, okay. Let's see. I've got x squared, x's. I have y squared, y's. Constant. All right. So I'm going to put my x squared together with my x's. Leave a spot. And y squareds. And y's. And of course, add the sum. All right. Now we're going to complete the square. Ooh. This one's ready to go. This we got to watch. Okay. I'm going to factor out a negative negative 4. I'm factoring out a negative 4. A negative 4. So that leaves me with y squared. And what's negative divided by negative? Positive. Okay, watch out. You're factoring out a negative. All right, now we're going to complete the square twice. First, I'm going to take my first b, divide by 2, and square it. All right, that's negative 1 squared, which is plus 1. I'm going to add 1. Now what about here? Positive 2 divided by 2 squared, so I'm going to add 1. But I didn't really add 1. What did I do? I subtracted negative 4 times 1, 4. Tricky. So I've got x minus 1 quantity squared minus 4 times y plus 1 quantity squared equals 8 minus 4. Getting close. Now I'm going to divide everything by 4. X minus 1 squared over 4 minus y plus 1 squared over 1 equals 1. 4 divided by 4. What is this with a minus? This is I heard it, hyperbola, which is really kind of the most complex, I think, of the 4. All right, it's a hyperbola. X squared, y squared minus. Okay. X comes first. Whichever one comes first, the x squared or the y squared is the transverse axis. It's like the major axis, all right? But it's horizontal, okay? Because really, what is the center of this thing? H1k negative 1. So the center is 1, negative 1, okay? So the transverse axis is actually down 1 here, okay? This is my center. All right, so what do I need for a conic? Well, I need the center. Okay. Then I need the vertices. Well, this is a squared. So a is 2. So where are my vertices? I go 2 to the right of the center, 2 to the left of the center, right? V1, V2. Here are my vertices. So I've got negative 1, negative 1, and 3, negative 1. Nice. All right, I've got some important stuff here. I'm missing a couple things. All right, what's my b? Well, b squared is 1, so b is the square root of 1, which is 1. All right, so now I'm going to draw this central rectangle thing. But not really. I'm just going to go up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. All right. I'm looking for these asymptote lines, right? Y equals positive negative 1/2 x plus something. All right. I'm going to draw them in. My ruler is actually crazily missing one of my favorite rulers, and I don't know who took it. Could have been Leo, could have been Zoe. Most likely I just misplaced it, but I should use a ruler. I don't have it. Okay. And I'll draw in the hyperbola. I'll put in blue. It's beautiful. Nice colors. All right. Let's find the equations of these lines. Okay? I don't know the question marks. I don't know the 2 intercepts, y-intercepts. I can guess, but I want to know for sure. I'm going to take this center point and plug it in. Take the center and plug it in. And for y, I go negative 1, and then I'll go half. And what's x? 1 plus question mark. Subtract a half. The question mark is negative 3/2. So I have y equals 1/2 x minus 3/2. So the positive sloping line has -1.5. Yes, looks good. All right, then I go -1 equals -1/2 times 1 plus the question mark at 1/2. Ooh, my other question mark is -1/2. So the slope is -1/2. So is the y-intercept. Interesting. Can happen. All right. Are we done? Almost, you say, because the last thing we need is the foci. Now, to find the foci in a hyperbola, it's the regular Pythagorean. A squared plus b squared equals c squared. That's 4 plus 1. C squared is 5. C is the square root of 5. Which is about what again? 2.24. Now I know this is exact. Okay, well, we'll write the foci exact. What are they exact? Well, from the center I go 1, 2.21. First focus, and then 1, 2. Second focus. All right, pretty close to the vertices. The foci are at, what's the x value? Well, we start at 1, and then we add and subtract c, square root of 5, and the y is -1. Here are the foci. Whew. All right, hyperbola. Okay, so we did it. A whole bunch of review problems for the conic test. Know your formulas, and best of luck. Until the next lesson.